guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at how we can use the discriminant. So before I begin the video, please make sure you perform an LSS, that is like, share and subscribe. Also, if you are uncomfortable while solving quadratic equations, you should look at my video at solving quadratic equations with both the factorization method and using the formula, because in this video we will be using a lot of that. So without wasting much time, let's begin. So what exactly do I mean by discriminant? The discriminant is nothing but this. It's b squared minus 4ac, where b, a and c are in a quadratic form respectively as ax squared plus bx plus c. So your b, that's your b there, your a, that's your a there, and your c, that's your c there. If you pay much closer attention, you would recognize that this b squared minus 4ac is part of the quadratic formula as well. It's what's inside the square root. Now it depends a lot on the question, but the questions that I will be focusing on in this video will be the ones that involve lines and points of intersections. So there is a ground rule that you need to know and basically just memorize. So if the question says something like 0 real roots or no intersection, no point of intersection, then you know that your b square minus 4ac, that's your discriminant that's here, you would equate it to less than 0. If the question says 0 real roots or no point of intersection, then your b square minus 4ac will be equated to 0. Now before, of course, it sounds easy, b square minus 4ac, but obviously you will be given a few equations, and the first thing you want to do is get that whole equation into the form of ax squared plus bx plus c before you apply b squared minus 4ac and the designated sign. So if it is 0 real roots or no points of intersection, then you do is less than to 0. If it says 2 real equal roots, or it says a tangent to a particular curve, or it says 1 point of intersection, then all you have to do in this case is equate it to 0. So this is simply just equals to 0. And if it says 2 distinct roots, distinct simply means 2 different roots. So like as you see over here, it's equal, distinct means different. If it says 2 distinct roots or 2 points of intersection, then in this case all you have to do is it's going to be the b squared minus 4ac, the discriminant is going to be greater than 0. So of course, for now it may seem a lot to memorize, but with practice it will gradually just be stored in your mind. But you need to know this ground rule. This is the basic ground rule. You need to know when you need to use less than 0, when you need to use equal to 0, when you need to use greater than 0. So let's actually go into our first example, because this is also one of the topics that you understand much better when you do examples. Right, so this is how a question on discriminant looks like. It says find the set of values of k, for which the line y equals to k into 4x minus 3 does not intersect the curve y equals to 4x squared plus 8x minus 8. So we need to get a couple of information here. We know that we're trying to get something for k. We have 2 equations, y equals to k into 4x minus 3, and we have y equals to 4x squared plus 8x minus 8. And we also have the information that it does not intersect the curve. As I said from our ground rule, if there's no intersection, then our b squared minus 4ac is less than 0. But before that, we need to get it into this form, ax squared plus bx plus c. So let's get the equation to that form. If it says y is equal to 4x squared plus 8x minus 8, and it says y is equal to k into 4x minus 3, we know that we can simply write this as 4x squared plus 8x minus 8 equals to k into 4x minus 3. Since y is the subject in both these equations, we can simply equate k into 4x minus 3 to 4x squared plus 8x minus 8. So we can expand this side, so this will now be 4x squared plus 8x minus 8 equals to 4kx minus 3k. If you are uncomfortable in expansion of brackets, you can watch my video on expanding single, double and triple brackets. Now, as we know, we need to get it back in the quadratic form, and we know that ax squared plus bx plus c is eventually equated to 0. So this means that we need to bring everything to one side. So let's take all of this to this side here. So we now have 4x squared plus 8x minus 4kx. I'll just tell you in a second why I wrote minus 4kx before minus 8. Minus 4kx plus 3k minus 8 equals to 0. Of course, the minus goes over here and becomes positive, and the plus 4k goes over to the other side and becomes negative. Now, the reason I wrote 8x minus 4kx first, because ideally I would have written 4x squared plus 8x and then minus 8 and then the 4x minus 3x part. But the reason I wrote it like this is so that it's easier for me to factorize, because as I said, you need it in the form of ax squared plus bx plus c. We can see that we have the ax squared. This is the 4x squared. We need to get the bx and the c. And the way we get the bx is simply by factorizing this. So all we have to do now is this becomes 4x squared plus x into 8 minus 4k plus 3k minus 8. So what I've done here is I've simply taken the x, the common x over here, and factorized it, because you know that if you were to expand this bracket here, x times 8 would give you 8x again, and x times minus 4k would give you minus 4kx again. So it's basically, I've just factorized it out so that now I have a bx as well, because simply in this scenario 8 minus 4k simply becomes my b. So my a becomes 4, my 8 minus 4x becomes b, because that's what's related to x, what's attached to x. We're looking at what's attached to x, what's attached to x squared, which is 4 in this case, and what's c. Now you may be saying that c is minus 8 only, but all of this is c. Anything that's not attached to x squared or x, it's all c. Now that we have our a, b, c, we can use our discriminant. Our discriminant, as we know, is b squared minus 4ac, and in this case the sign is less than 0, because there's no point of intersection. This is c. Now we can substitute our values here into this formula. So we have 8 minus 4k squared minus 4 into 4 into, I think it was 3k minus 8. Yep, 3k minus 8. So I'll now just expand this. Please, if you are unsure of how to expand brackets, please watch my video on single, double and triple bracket expansion. So expanding 8 minus 4k, if I'm not wrong, I should get 64 minus 64k plus 16k squared. I just jumped a step here for the bracket expansion because I'm expecting you should know how to expand brackets properly, so I won't be going to that because that is not the sole purpose of this video. So 64 minus 64k plus 16k squared, then minus 4 times 4, this becomes minus 16 into 3k minus 8. Remember, it's all still less than 0, although you know you can treat the inequality sign as as something like an equals to sign. Like you can equate it, you can simply treat it as an equals to sign. So doing, or rather writing our next piece of information, we know we now have 64 minus 64k plus 16k squared minus 16 times 3, that's minus 48k, and minus 16 times minus 8, I think that is plus 128. Remember, 2 minus make a positive, because minus is the most dangerous sign in math. Oh, this is 0. So collect your like terms. You only have one term with k squared, so this is done. This is 16k squared. We have minus 64k here and minus 48k. So minus 64 and minus 48, that should be minus 112. Let me just quickly check. Yep, minus 112k, and then you have 64 plus 128. That should be plus 192. Equated or less than to 0. As you can see, we now have a quadratic formula in the form of ax squared plus bx plus c again. So as I said before I began the video, you should have a look at my video on solving quadratic equations if you're unsure on how to solve them. So I'll just go ahead and solve it. I know this is either k minus 4 or it is k minus 3 less than 0. As I said, this can simply be, you can also write equals to, there's no real harm, but I'll just write less than. And then I know that k is 4 or k is 3, because the minus 3 would go to the other side and become positive 3, and the minus 4 would also go to the other side and become positive 4. So now that I have two values, I need to check what values are correct, but because it's not necessarily that the final quadratic answers you get are correct. So what you have to do is you have to take certain numbers and input them back into this quadratic equation here and see if it satisfies the inequality. So I have 4, I have 3. So let me test a few values. A value that's bigger than 3, a value a value that's less than 3, so let's say 2, a value that's greater than 4, let's say 5, and a value that's in between 4 and 3, let's say 3.5, because you need to know how to structure your answer towards the end. Okay, not you. Okay, so let's test with 5 first. Let's put 5 into all the places of k in this quadratic equation over here. You always put it into the quadratic equation you get after using the discriminant. And let's see that if we put 5 in places of k over here, does it satisfy the inequality? Is the answer less than 0? So 16 into 5, of course, using a calculator, 16 into 5 squared minus 112 into 5 plus 192 is, okay, sorry, let me just do it again. 16 into 5 squared minus 112 into 5 plus 192. Okay, I'm getting 32. So when I put 5 into this equation here, I'm getting 32. So that obviously doesn't satisfy the inequality, because it says the answer is meant to be less than 0, not greater than. So this is wrong. Nothing greater than 4 will satisfy the inequality. Let's try something less than 3. Let's try 2. So again, we put 2 into that quadratic equation. So 16 into 2 squared minus 112 into 2 plus 192, and I'm getting 32 again. So if I'm getting 32 for 2 as well, this is wrong, because it's meant to be less than 0 and not greater than 0. So this is wrong. Now let's try 3.5. If I put 3.5 into k, 16 to 3.5 squared minus 112 into 3.5 plus 192, I am getting minus 4. And minus 4, as we know, is less than 0. So this satisfies the inequality. And if 3.5 is satisfying the inequality, as we know, it's a number between 4 and 3. That means any number between 4 and 3 will satisfy the inequality. So your final answer, the way you would write it as your final answer, the way you would present it is something like this. That your final answer of k is, so you would write 3 is less than k, which is less than 4. this simply means that your k is in between 3 and 4. Now you may be wondering why I used 3.5. I could have used any number between 4 and 3. It could have been 3.1, it could have been as small as 3.0001, and I would have still gotten a negative answer. The most important thing is for you to check your answer with a number. So if you get two values with a number smaller than the smallest value you got, which was 3, a number bigger than the biggest value you got, that is 4, and a number in between the two values you get. So that's basically the final answer for that question. And as you can see, this is a long process, so please make sure that your algebra and your workings are always correct and shown. On to the next example. It says find the values of k for which the line y plus kx minus 2 equals to 0 is a tangent to the curve y is equal to 2x squared minus 9x plus 4. So from the ground rules I started with, if it is a tangent, we know that our b squared minus 4ac is simply equal to 0. So it's just equal to 0. So let's go. I know that y is equal to 2x squared plus minus 9x plus 4. But over here y is not the subject. However, we can make y the subject. We have y plus kx minus 2 equals 0. If you make this the subject, we have y the subject of the formula. Y is equal to 2 minus kx. Please, if you are uncomfortable in making anything the subject of the formula, you can watch my video on rearranging the formula to make x the subject. In this case, we're simply making y the subject. So now that I have y equals to 2 minus kx and y equals to 2x squared minus 9x plus 4, I can equate them. So I can do 2 minus kx equals to 2x squared minus 9x plus 4. Collect my like terms. I need to bring everything to one side. Let's bring both of this to this side. So I will now have 2x squared minus 9x plus kx. Again, I wrote the x's together so it's easier for me to factorize. Plus 4 minus 2 equals 0, because you want it in a quadratic formula. You want it in ax squared plus bx plus c. So simplifying this, we have 2x squared plus x into minus 9 plus k plus 2 equals 0. y2 because 4 minus 2 is 2, and yx into minus 9 plus k because I simply factorized. I just did x into minus 9, which gives me minus 9x, and then x plus k would also give me plus kx. Now that we have it in our form of ax squared plus bx plus c, because we know that this 2 is our a, this minus 9 plus x is our b, and this 2 is our c. So again, using our discriminant, that's b squared minus 4ac, and in this case it's simply equal to 0 because it said in the question it's a tangent. So our b is minus 9 plus k, so minus 9 plus k squared minus 4 into 2 because that's our a, and then into 2 again because that's our c, equal to 0. Expanding this, I'll just skip a step because the purpose of this video is discriminant and not expansion of brackets. Please, if you are uncomfortable in expanding brackets, do watch my video on expanding single, double and triple brackets. Expanding this, I'm getting 81 minus 18k plus k squared minus 16, because minus 4 times 2 is minus 8, and minus 8 times 2 would give minus 16. All this equal to 0. Collecting your like terms, this is k squared minus 18k, and then 81 minus 16 is 65, I think. Yes, it is. Oops, not 6k, 65. This is k squared. Okay. So now again, we solve this. I can factorize this out. I know this is k minus 13 into, or k minus 5 equals to 0. I know that k is either 13 or k is 5. Now if I want, I can test these values, because as I said for the previous example that you should test your values you get at the end. But since the discriminant is equal to 0, I know that these are the correct answers because I am getting equal to a value. So this is a trick basically, that whenever your discriminant is a tangent, or whenever you're using the inequality or the equals to sign, then your final answers, your final quadratic answers you get are the correct answer, you don't need to check, because that can save a lot of time during exam conditions. But if it's greater than or less than, then you have to check if what values are correct. So that is the answer for that question. And on to the final example for this video. It says, find the range of values of k for which the equation kx squared plus x is equal to 8x minus 2xk has two real distinct roots. If it's two real distinct roots, our foundation, or that foundation rule as stated earlier, this means that simply b squared minus 4ac is greater than 0 if it's two real distinct roots, two real different roots basically. They have made it a lot easier for us in this case because they've equated it for us already. We don't need to do the hard work. So right away, kx squared plus k equals 8x minus 2xk. Let's collect every term on the left side. So this will now become kx squared minus 8x plus 2xk plus k equals 0. Y minus 8x, because this 8x goes and becomes negative. Y plus 2xk, because this goes over here and becomes plus 2xk. And I wrote the two x's before the plus k because I know I have to factorize the x out. Of course, it may not always be that you have to factorize, but in most cases it is. So now I have kx squared plus x into minus 8 plus 2k plus k equals 0. Of course, do remember that we are using this greater than 0. I'm just writing equal to 0 now because sometimes it's better to use equal to 0, but do remember that when you do test your final answers, you have to take in consideration the greater than 0 sign. So we have our a, we have our b, we have our c. Our a is what's attached to x squared, that's k. Our b is what's attached to x, so 8 minus 8 plus 2x, and then our c is the term independent of x, which is k. So we now do b squared minus 4ac is greater than 0. B squared, that's minus 8 plus 2k squared minus 4 into k, and this also into k, and all of this is greater than 0. So all I do is I simply substituted the a over here, the b over here, and the c over here. So expanding this, please, if you are not sure on how to expand brackets, do watch my video on expansion of brackets. Expanding this is 64 minus 32k plus 4k squared, and then this is minus 4 times k is minus 4k, and times k again is minus 4k squared, greater than 0. So this and this would cancel out because plus 4k minus 4 plus 4k squared and minus 4k squared is 0. So this becomes easier for us. We have 64 minus 32k is greater than 0. Now if we're solving for k, we know this is minus 32k is greater than 0, sorry, not 0, greater than minus 64, because 64 will go to the other side and become minus, and then k is nothing but minus 64 divided by minus 32, and that is positive 2, because the 2 minus will become a plus. Do remember minus is the most dangerous sign in math. So now let's just check for the values. So even though I know that this is the right answer because we only basically have one value, that's 2, but let's just check it for the sake of it. If I put any number that's, let's say, less than 2 over here, so 64, let's say I put 1 minus 32 into 1. Okay, so as I was saying, sorry, there was a little delay. Right, so let's try and put 1 as k over here. If we put 1, which is a number less than 2, we know that 64 minus 32 into 1 would give me 32, which is greater than 0 actually. So this actually suffices the equation, so that means putting something less than 1 is less than 2 rather is correct. So let's try and put something greater than 2. Let's put 3. Let's put 3 into k over here. So 64 minus 32 into 3 is minus 32, and that's not greater than 0, that's less than 0. So actually this question even caught me off guard. this is actually not the right answer. The answer is k is less than 2. And this simply emphasizes the fact that you should always check your answer once you have it by putting a value less than the answer and a value greater than the answer. In this case, we only had a single answer. So the actual value is k is less than 2 and not k is greater than 2. So please always do remember to check your answer at the end of your working. And that brings us to the end of this example and to the end of this video. Thank you for watching, guys. Hopefully you enjoyed it. Please do perform an LSS, that is like, share and subscribe. And thank you for watching. Have a nice one, guys.